Get rolling here with systems by graphing. You basically are going to have three options that can come up when you graph two lines. They can cross at one place where you have one solution. If you get the one solution, though, we don't want to just say, hey, one solution. We actually want to know what the value of that solution is. And we're going to do that as a coordinate point, not as x and y equals. Those are lines. So left 1 to -1, up to get to my y value. So please, please, please make sure those are in coordinates. The other two are both kind of special cases. If they don't cross at all, like these do, I will write in the middle of them because that sounds, oops, no solution. But let me take that one step further. There's a way, if you don't have a graph, to tell if there's no solution. And that's going to be if your lines are parallel, or if you remember back to seeing this before, they have the same slope. So if you look at two y equals equations, and they both have slopes of 1/3, there's one other thing we'll have to look at, but typically they're going to be the same slope. We'll make them parallel, unless we hit our final option, and you work through and you find out it's the exact same line. You have two lines on top of each other. That's a little harder to see at the beginning, but if you get things into y equals, you'll see it definitely because it'll be the same y equals equation. This happens most often, and then these just a little bit now and then, but we got to be prepared. We know how this works. And so when we go to graph systems, you're going to want to get as many points as you can if you're doing it without a calculator, because you never know which point's going to be the magic point. Case in point, I'm going to try and do this with colors to make it a little easier to tell. We want these in slope-intercept form. So if they're not, that's my first job. So I'm going to minus my x over on this one. If we want to put the slope in the front with my 1s to remind me, that's not a problem. And on the second one, we got a little more work to do. I'm going to subtract my x over, but my y is still not by itself because it's negative. So we're going to divide through by -1. And get that in there. So here are my two equations that I'm working with. And again, if you're decent at graphing lines, hopefully you would be at this point, do my y-intercept first, not x. And then my slope is -1/1, so I'm going to go down 1 and right, down and right, down and right. Normally, this is more than enough points to make a line. If you have a straight edge, it's probably enough. But if it's not, or if you're going to try and quick sketch, I would also suggest then, instead of down and right, also going up and left to make as much of a literally dotted line as I can. Just because accuracy is going to be of great importance when we're doing these. But having more dots is going to keep us out of trouble more than likely. And then we do the same thing here. -6 for my y-intercept. My slope is just 1/1. So we go up 1, right 1, up 1, bingo, right 1. Once you see where the actual connection point is, again, don't just circle it. Work your way over on the x-axis to line up with it, and then move your way along y to get there on that one. Again, not going to be too bad. Not going to be too bad. And so if we play that one more time on the second one, but I'm going to freeze frame on this one. Try to play the graphing game. Get your equations ready to go here. If we need a little assistance on things, I'm here. Just wave me down. Should end up on a whole number if things go well. I'll just mention while you're looking at it again, this is going to be another one of those problems where a majority of the ones that you run into are going to be like these two. Sometimes you'll get lucky and it'll be in y equals already, but most of the time, a little bit of solving, and then just graphing with a line and slope-intercept form should get us into pretty good shape. So just a couple of quick notes on this one. You should have gotten the coordinate point 1, 2. Again, if you don't have a y-intercept, if you don't have a plus or minus, we assume it starts at 0. It starts at the origin. And if you have a whole number slope, remember, it's up or down that many and then over 1. Like here, I can't just keep going up 2, up 2, up 2. I'm going to end up with a vertical line. So always remember that little piece, and it will save you a whole lot of trouble with things. So, again, that's the norm. But again, you know how we are in here. We don't always just want to do the norm. That's boring. So we're also going to run into some situations where we're going to get fractional or decimally stuff going. We don't really want to mess with those on our own. That's going to be a pain. So when we get into that situation, we're going to use the graphing calculator to help us out. So we got all of our button presses here to help us if we need them. So let me move this up. So we are going to go to y equals, whatever craziness may be in there, we're going to wipe out. And so let's see here. So we got 9x plus 20 and 2/10 x plus 10. And if you want to see if it fits already, you can just hit graph. But purposefully, a lot of the times with these, they're not going to fit. So if you use zoom and 0, which is going to fit the graphed equations in, that's going to be your best route. So we get in here, and we can see, okay, they cross right here. So to get what that point is without having to do a bunch of other work, we're going to do second trace, which is the calc button. We want to know where they're going to intersect. So we hit enter, and it starts asking these questions on the bottom. This normally confuses people. They're like, first curve, there's no curves here, it's 2 lines. Okay, we're going to ignore all that stuff. That's why it says enter, enter, enter there. That wasn't like the button getting stuck. I hit enter for the first curve because I don't need to do anything. I hit enter for the second curve. I don't need to do anything. And I hit enter for the guess because I don't feel like doing it. Now it tells me the intersection, which I never would have come up with that in a million years if I graphed it by myself. So negative 1.14. Normally we're going to go to the nearest hundredth. If you go to a tenth, that's okay. I don't care. And I've got my point of intersection. Because life normally doesn't just give us whole number clean answers on everything. Why should math be any different? And so, as you're trying these, yeah, I'm going to freeze again. Why not? Use those keys up above, kind of as a guide. Try playing with getting them in. Again, if you run into trouble, oh dear, let me know. I will come try and get you fixed up here. Definitely not clean numbers on this one. That all that other stuff, but X is first. That'll get you X. You wouldn't think so with all the other junk they put on there, but one tricky thing with the calculator stuff is like you just have. It's like you got to go on a leap of faith here. That okay, I typed in everything right, and everything went well. I mean, yeah, if I would have typed in, like, let's say I forgot a decimal or I forgot the negative, I'm still going to get an intersection. So you've really got to be cautious on these to make sure that you're giving everything its due time. Make sure it gets you to the right spot here. So you do. And you have those options to do that even on the others, but you've got to be in y equals first. Because you can't type X and Y into your calculator and try and do it in these funky forms. It just won't work. Okay. So now, one more little piece to the puzzle here. Because graphing's straightforward enough, I thought we could handle two things at once here. So solving a system by substitution. Okay. Typically, and I like to underline this because we can do substitution on almost any system, but preferably, one of your equations at least already has an x equals or a y equals, an isolated variable. That's going to make it the simplest. I really don't want to do substitution if nothing's an x or y equals. So, we can still have the special cases. Okay, if your variables cancel out and the constants are the same, you get 0 equals 0, 6 equals 6, whatever it is. Okay. Infinite solutions are all reals. We can say that as well. If the variables cancel out and the constants are different, 0 equals 7. 0 doesn't equal 7. No solution, okay? No real solution. Because there could be complex or imaginary ones. That's still coming. I say that every time we run into this, but it's coming. So solve each substitution system by the substitution method. Show your work. Okay. Hardy, I could just put this in the calculator. I know. It's a nice check, but we're not going to do that. Okay. I'm going to take my first y equals here. And I'm going to plug it into the y equals in my other equation. So my first job here, y is gone, replaced with 3x minus 10. The right side stays the same. Well, why'd you do that? Because I just went from 2 variables down to 1. We got to solve for one variable before we can find the other. And so once I do that substitution, minus my 2x over, add my 10 back. Okay, I've got my x value. Sweet. This is just how I go about it because I'm not as... So for step 2 now, I want to know what y is. So in this particular case, these are both y equals. You can pick either equation. It makes no difference which one you pick. Bless you. And we're going to start going along until we get to x. But now we know what x is, so we're going to substitute the value in. 15 minus 10 is 5. Make my coordinate. If you're not sure, maybe sometime you get a fraction or something like that. If you do, okay, you can always substitute them in. 5 equals, let's see, 15 minus 10. Yes. 5 equals 10 minus 5. Yes, okay, that worked. So that's how these are going to work. And the variable that you use can change. Here, I see an x equals. So I'm going to use what x equals, and I'm going to plug it in for x in the next equation. Make sure you plug it into the right spot. So 2, the 2 didn't go away. Y minus 3 plus y equals 18. The only thing that changed is x went bye-bye and got replaced by what's in the box. Everything else, Algebra 1 stuff. And just again, it's little stuff. Your y's are on the same side of the equation. Don't do opposites. Just put them together. Add my 6. Divide by 3. Now, even though I said on the last one, you can plug it into either, and you can. If one of them already is nicely set up for you, use it. That first equation is set up sweet for me because I want to figure out what x is. X equals, what does x equal? It equals y minus 3. Okay. I'd get the same answer if I plugged it in here, but I got to do more work. I don't want to do that. That'd be silly. So one last one. I'm gonna give a, I guess I'll call it a hint before I freeze frame for the last time. Well, wait a minute. This time I got one x equals and one y equals. What do? It doesn't matter. If you want, box this in and plug it in for y. If you want, box this in and plug it in for x and the other. They both work. Either one will get you to the same answer at the end. So substitute your pick. You don't even have to. You can get to be choosy this time. Plug it in there. Okay, I was going to say, I hope I was freezing it. So it'll specifically tell you on instructions, solve by graphing, where you're either going to graph it on your own or if it's decimally or fractionally, then I'd go to the calculator. Versus these, it'll say solve by substitution, show your work. So yeah, and I'll explain that a little bit when we get to the actual practice here in a minute too. There'll be some occasions where I'll give you an option and say, hey, here's a system, solve it. You're like, well, which way? I don't know, whichever way you think is best, but I won't do that until you have all the options. But you've still got a couple of options left that we're going to talk about tomorrow. Unfreeze here so some of you can see as we're going along here. I went with plugging in the y equals equation into the second. Like I said, it would work even if you went the opposite way. You just get the y answer first instead. Then you can always pop in to make sure they work, especially if they're simpler like this. And rock that out that way. So when you're doing these, we will get to a point where you can kind of look and say, hey, this will be easier than this. I'll do it this way. Or, ooh, that's kind of hard. I'd rather do it this way. And that's fine. But for the time being, you're going to have direction on, hey, do this way or do this way until we get those other pieces in the puzzle. So what I'm going to have you do, and yes, I know I'm freezing frame here for just a second because I know a couple of you are still getting a couple of things down there. So when you're doing the practice on this, the practice is on 3 and 4. Graph each system and find the solutions. Okay, that's as direct as it can be. You've got to get into y equals if it's not. And then it's up to you. If you want to take the y equals and put it in your calculator, I still want the lines graphed, even if you decide you're going to go the calculator route. I want to make sure we can graph lines. Because if that's a struggle, we got to get that fixed right away. So the nice clean ones are up top. Down below, here comes the decimal stuff. That's where we're going to go to the graphing calculator, and I'm not going to have you graph 6.1x minus 12. No, we don't need to do that. It just lets us make sure the calculator's working. So have your notes out if you kind of don't have a lockdown on what that looks like. And then the back is all substitution. Some are nice and solve for x or y in one spot. Some is you have a choice. Some is you just plug them in. Again, I'll say like I always do. I can even put it on film here. Odds at a minimum. If you get them all right, then you have a choice to make. Okay, am I good enough, or do I need to do a couple more to make sure? That's your call. If you're missing them or struggling, you need to keep practicing them until you're not screwing them up. This test is too important for some of you with trying to bump other grades up and things to not be fully prepared, because you know how the tests are in here. You've got to know what you're doing, or you're going to run into a time crunch.